Okay, so we're going to kind of pick up where we'd left off, except I want you guys to do all those practice ones. Okay, and if you don't want to use a model every single time, that's fine. We're going to explore what I showed you last week and go ahead and start talking about the steps to solving one-step equations and talk more about inverse operations. Okay, so we're on M3 112. This is really quick to get to our 3.0. Okay, so an equation can be solved by using one operation. So how can you use what you learned from creating bar models to solve any equation? So we're going to take a look at that. Now that you understand the bar model, you can write equivalent equations with the same structure, while you can use reasoning to determine the value for the variable that makes an equation true. You can also use properties and inverse operations to isolate. Isolate means alone, by itself. Okay. And we want to do that with the variable. Sorry, I kind of stopped short on that. So we're going to take a look at inverse operations, are pairs of operations that reverse the effects. For example, subtraction and addition. So we kind of talked about this. Subtraction is the inverse of addition, and then vice versa. Multiply and divide are also. So be on the lookout for those quick questions and getting very, very familiar with that. Okay, let's move on. Page M3112, here's a worked example. And when you can do something like this all by yourself, that's going to be a 3.0. Of course, with this worked example, we're getting help. We're starting out with 8 plus 6 equals 19. Now, I know a lot of you can just use your mathematical reasoning and tell me the answer to that. Okay, but we want to go with these easier problems and learn how to use the inverse because that's going to help us later on. So remember, we want to get h by itself. Okay, we have plus 6, so we're going to do the inverse of that and subtract 6. And remember, I like to think of that teeter-totter and a balance. This is also kind of like a lever in science class. So we want to keep the same amount here, okay? And it has to be the same amount on this side to keep our teeter-totter or our scale balanced, okay? This is the equal sign. Some teachers like to put a line all the way down there, so you can do that if you want to. Now, by saying all that, I want you to understand that since we subtracted 6 on this side, we have to subtract 6 on this side. And I forgot to mention here, they took 19. Remember when we broke it into those models? And they broke that into 13 plus 6 because we have the 6 on this side. That just makes this subtraction a little easier. Okay. If you don't want to do that, you can simply know that you're going to have to take 6 away from 19 to get your answer. It's really the same thing. After we do all that math, we know we have h plus 0 and 13 plus 0. So that lets us know that those zeros can kind of fall away, and we have h equals 13. Now, you're going to learn more about this when we dive into vocabulary, but that's the additive identity property. The additive identity property says anytime I add 0, I'm always just going to get, being cranky with me, I'm always going to get that number. So I can add it to h, it's going to be h. I can add it to 13, it's going to be 13. I can add it to 2000, it's going to be 2000. We call that the additive because it has to do with adding. Identity because the identity of the number, what it is, does not change. Okay. Now, so what is the solution to this? Well, we know that h is going to equal 13. Okay, let's move on. Page M3, 112. Let's see, are there other solutions to the equation? Can it equal anything else? Well, no, because we did the math and there were no other answers. There's no other answers. Okay. Now, Use the same strategy to solve this equation. Okay, so I'm going to walk through this one with you. I see my unknown or my variable right here. And so I want to get it alone. I want to isolate it. What's with the m? 12 plus. So what's the inverse of 12 plus? Minus, right? Okay, let me draw that line down here for my equals. And remember, what I do on one side, I have to do on the other. Now, I want you to notice the way I'm setting this up, and then I like to kind of draw an equal sign. I can see the math right here, and I have it set up and lined up to where all I have to do is subtract. So I can simply know that if I have 12 and I take away 12, I'm going to be at 0. 0 plus anything is going to be that thing, so it's going to be m. And I can simply do the math on the left-hand side here that I have highlighted yellow and have my answer. So 5 take away 2 is 3, and 3 take away 1 is 2. It's that easy. Now I want you to try on number 2. This is a 3.0 skill right here. Okay, you show me that you can solve this, and I can put a grade as an A in the grade book. Okay, so go ahead and pause and do that. Raise your hand when you want to show it to me. Okay, I hope you were successful at that. Number 3 really just kind of walks us through some strategies, and we have Kanaya here. She says, when solving the addition equation, I can simply subtract 7 from both sides without first writing an equivalent equation. So see, she did not break 11 up. Okay, that's kind of what I did. So I did it exactly like Kanaya does. Okay, now we're going to work with these properties a little bit later when you start building your vocabulary with Miss Allison or our small group in the back. Let's see. How could Kanaya check her solution? This is really important too. So if I think the answer is 4, I can literally go back up, and this is what you guys did for your last target. And instead of the m, I'm going to put a 4. So instead of m plus 7, I'm going to substitute the answer. I'm going to solve it. So I'm thinking, well, 4 plus 7 is 11. Is that exactly what was here? It is. So I know that I'm correct. This is one of my favorite kind of math because you can check just about every single answer. Okay, so that's something that you can do too. Now, the numbers are getting bigger, okay, but you keep the math the same. I can see that my y is right here. To isolate or get it alone, I have plus 120, so I want to do the inverse, which is minus 120. If I do that math on one side, I have to do that math to the other side. I know on the left-hand side, 120 minus 120 is going to give 0, so all I have left is the y. So when I complete this math, I am done. 5 take away 0 is 5. Ooh, I have to borrow. 11 take away 2 is 9, and 2 take away 1 is 1. Whew, that was a mouthful. Now I'm going to go to a blue pen and I'm going to check myself. So my original statement is 120 plus y equals 315. And I think y equals 195. So I'm going to put that in instead of y. And I'm going to stack it so I can add it easier. Okay, 0 plus 5 is 5. 2 plus 9 is 11. 1, 2, 3. 315. So is 315, I'm going to bring this down. Does that equal 315? Yes, it does. So I know that I'm correct. If I didn't get 315, then I got to go back and check my subtraction. Okay? Now, you see some fractions. Try the fractions. If you can't do the fractions, just mark them off. Okay? Make it simpler. We'll pick some different numbers. I'm going to give you a higher score if you can do the fractions. So no worries there. Decimals, I really hope you could line those decimals and subtract. So I really want you to give it a try, okay? And basically what I'm looking for is for you guys to try to complete these on your own, okay? So I'm going to leave the video here. You guys have on the same page, M3114, there's B, C, D, E, F, G, and H. So do what you can, show me as you go, and I'm going to go ahead and grade that, okay? Good job and keep up the hard work.